The open ocean is in constant motion, carrying long wavelength waves moving at relatively high speeds. Under steady wind, the amplitude of these waves can get quite large. Suppose a boat is at rest in the open ocean. The wind has created a steady wave with wavelength of 190 meters, traveling at 14 meters per second. The top of the crest of the waves is 2 meters above the bottom of the troughs. A, what is the maximum vertical speed of the boat as it bobs up and down in the passing wave? B, what is the maximum vertical acceleration? Okay, here's what we need to do. There's a wave which is going by. A boat is sitting there bobbing up and down as the wave passes by. What can you tell me about the motion of the boat? How would you describe it? It's simple harmonic motion as the wave passes by, okay? So this is a simple harmonic motion problem. Now, remember, we had some relationships that told us what the maximum speed and the maximum acceleration are for a simple harmonic motion. It was this. The maximum speed was equal to 2 pi f times the amplitude. The maximum acceleration was equal to 2 pi f squared times the acceleration, times the amplitude. Those are our two expressions which we're going to need to evaluate. In order to be able to do this, I need to know two properties of the wave. What are the two things that I need to know? The frequency and the amplitude, Okay, the top of the crest of the wave is 2 meters above the bottom of the troughs. So the high point of the wave to the low point of the wave is 2 meters. What's the amplitude? 1 meter, okay? It's only half of that because the boat's going up by 1 and it's going down by 1. So amplitude, 1 meter. The other piece we need to know is the frequency. Oh, we're not given the frequency, but we are given the velocity and we're given the wavelength. And so I can use this expression. Velocity is equal to frequency times wavelength. And I'll just recast it this way. Frequency is equal to velocity divided by wavelength. The velocity is 14 meters per second. The wavelength is 190 meters. And so the frequency is 0.074 hertz. And that makes sense. The crests are 190 meters apart, and they're traveling at 14 meters per second. So it's going to take a while for one wave to hit you and then the next wave to hit you. It's more than 1 second between adjacent crests. And so the frequency is going to be less than 1 cycle per second. Oh, so we have the frequency. I have the amplitude. And so I can calculate the maximum velocity. I can calculate the maximum acceleration. And if I do that, I get a maximum speed of 0.46 meters per second. It's about 1 mile per hour. And I can also get a maximum acceleration. And again, I've got the frequency. I have the amplitude. I can calculate straight away. And what I get is 0.21 meters per second squared, which is equal to 0.02 g approximately. It's 2% of the acceleration of free fall acceleration. That was the same as the acceleration at the top of the building, sloshing back and forth. If a wave like this goes by on a boat, you get seasick. If you're on the top floor of that building, you get seasick. Turns out it's slightly different because you're more sensitive to this than you are to this. But it's the frequency and at that magnitude of acceleration that's crucial.